So, welcome back to the last part of this exercise, 12.3 of chapter 12, area related to circles. So, question number 13. In the figure, OABC is inscribed, it's a square inscribed in a quadrant OPBQ. If OA equal to 20 centimeter, find the area of the shaded region. So what is given here is the side of the square is given. Side. We don't have any other measure. So we need to find the area of shaded portion. So from the figure, it is very, very clear that area of the shaded region is equal to what? It will area of that quadrant. Area of quadrant minus area of square. Very, very simple one. So, area of the quadrant we have to find. Area of the square is very easy. Side into side we will get 20 square. To get area of the quadrant means 1 by 4 of area of square, that is 1 by 4 pi r square. But what is r here? R is not given. R means OP. OP is the radius. OQ also is the radius, but we don't know that. But we can find the area, diameter, the radius. Radius we can find. That means the diagonal of this square. Diagonal of this square is the radius of the quadrant. That is OP equal to OQ equal to OB. So let us find the diagonal. So since it is square, we can apply the Pythagoras property. So OB square. OB square equal to OA square plus AB square. It is equal to 20 square plus 20 square. That is 400 plus 400. That is equal to 2 into 400. So OB equal to root of 2 into 400. That is equal to, the root of 400 is 20. So it will become 20 root 2 centimeter. So we got this 20 root 2. So area of quadrant. Area of quadrant. Which is quadrant? Quadrant OPBQ is 1 by 4 pi r square. So r equal to, this is r, no? R. So equal to 1 by 4. And pi it is asked to use 3.14 given. So we have to put that value 3.14 into 20 root 3 into 20 root 3. So 20 root 2. 20 root 2 into 20 root 2 equal to 1 by 4 into 20 into 20, 400. 400 root 2 into root 2, 2. So 400 into 2, 800. So 3.14 into 800, I will write it as 8 into 100. Why? Because, so that 3.14 into 100, it will become 340, no, for that. So 1 by 4 into 314 into 8. Here I can cut 4 and 8. So 340 into 2, which is equal to 628 centimeters square. Next, So this is the area of quadrant. Next, we need to find area of square. That is 20 square, because side is 20, which is equal to 400 centimeter square. So now area of shaded region. Equal to 628 minus 400, which is equal to 228 centimeters square. This is the area of shaded part. Now, let us move on to the next question. Question number 40. Question number 14. Now figure. Very, very easy question. Question number 14. Okay. What we have to find? AB and CD are respectively arcs of two concentric circles. So AB is arc, CD is another arc of two concentric circle of radius 21 and 7 centimeter and center O, and the angle AOB same as COD, it is given as 30 degree. Find the area of the shaded region. So very, very simple one. Area of shaded region will be what? These two are sectors, no? So area of bigger sector AOB minus area of smaller sector, not AOB, OAB, OAB, and area of smaller sector OC. And we know the radius, we know the angle. So OA equal to OB equal to, let me take it as capital R, which is equal to 21 centimeter, and OC is equal to OD equal to small r, which is equal to 7 centimeter, and theta is 30 degrees. That's all. We got all the information we need. So area of the shaded region, area of bigger sector, which is equal to theta by 360 pi r square. Here I will take capital R minus theta by 360 pi r square. Here I will take small r. So theta by 360 pi is common. So I can simplify easily if I take it common out, which is equal to r square minus small r square. Now let us substitute the value. Theta is 30. So 30 by 360 into 22 by 7 and 21 square minus 7 square. That is 30 and 360 will get cancelled. 3, 36, 12 times. Now 6 2s are 12, 11 2s are 22. So here I got 11 by 6 into 7, and inside 441 minus 49. So which is 11 by 6 into 7 into 441 minus 49. What is the difference? 49. Subtract. 392. 392. And 392 is Not divisible by 3, but divisible by 7. So 56. So which is equal to 56 into 11. 56 into 11, what we will get? 56 into 11. 616. 616 divided by 6. Lowest form, both are divisible by 2. So it will be 308 by 3 centimeters square. This is the area of shaded region. Okay. Now let us move on to question number 15. Quite easy question only, but little bit more lengthy question. Not very simple question. Little bit. What is given? ABC is a quadrant of a circle of radius 14 centimeter and a semicircle is drawn with the BC as diameter. Find the area of the shaded. So it is given that quadrant, that is, which is the quadrant, this part and this part. This much is a quadrant of the circle. And with the BC as diameter, there is a semicircle. This whole part is a semicircle. So we have to find the area of the shaded portion. Area of the shaded portion means it is area of the semicircle minus area of this segment. Is it? And how we can find the area of the segment? Area of the segment will be area of this quadrant minus area of this triangle. Is it? So two steps are there. First, area of shaded region is equal to area of semicircle minus area of segment. And to find the area of segment, first we have to find that area of segment is equal to area of quadrant minus area of triangle BAC. So first let us find area of the segment. So quadrant, area of the quadrant is 1 by 4 pi r square. And it is given that radius 14 centimeter given. So quadrant radius. Quadrant radius is given, but semicircle radius is not given. It's not that quadrant radius is 14, but we don't know BC. Diameter, that is the diameter of the semicircle. That radius is not given. That we have to find out. So that we will find later. First, let us find here area of the quadrant and area of the triangle. That information we have, we can find that. So area of the quadrant equal to 1 by 4 pi r square, area of the quadrant, minus area of triangle BAC, half BH, no. So it's right angle triangle, so base into height, that is half AC into AB. So this is equal to 1 by 4, 22 by 7, 14 into 14, minus 1 by 2 into again 14 into 14. So 7, 14, 2 times, and 2, 4, 2 times, 2, 14, 7. Now here 2, 14, 7. So 22 into 7, 154 minus 98. So 154 minus 98, which is equal to what we will get, 56 centimeters square. So area of the segment is ready. Now we need to find area of semicircle. Then only we can subtract area of the segment from that. So to get the area of semicircle, we need to find radius of semicircle. So first let us find the diameter BC. So BC square is equal to AC square plus AB square by Pythagoras property. So 14 square plus 14 square, that means 2 into 14 square. So the square root of that will be 14 square root, 14 only, 2 then 14 root 2. So BC equal to 14 root 2. So BC is the diameter. So what will be the radius of the semicircle? Radius of semicircle. Half of that, no. So 7 root 2 centimeter. Now, area of semicircle. Area of semicircle will be half the area of the circle. That is 1 by 2 pi r square. So 1 by 2 into 22 by 7 into 7 root 2 into 7 root 2. Okay, we can cancel 7, 1, 7, here 1, 7. Here root 2 into root 2, 2. That will cancel with this 2, no? So, or we can cancel this 22. Whatever way, no problem. So here 11 into root 2 into root 2 into 7. So what we will get? Root 2 into root 2, 2. So 2 into 7, 14. Now 11 into 14. 11 into 14, what we will get? 11 into 14, 154. So this is 154 centimeters square. Now area of shaded region, this part, area of the shaded region equal to area of semicircle, we got 154. That minus area of the segment, we got 56. So when you subtract it, we will get 98 centimeters square. That's all. This is the area of the shaded part. So question number 16. Last question of this session of this exercise and last question of this chapter 2. Quite interesting and different type of question. Calculate the area of the design region in the figure common between the two quadrants of circles of radius 8 centimeter each. So observe the figure very, very carefully. So here two quadrants are there. So first we need to identify the two quadrants. So first quadrant, let us see. And the area between Here, this is one quadrant. And the next quadrant, other quadrant is this one. Now you can identify the two quadrant, is it? Okay. Now we need to find that area between them. So that means to find the area of that design is, first we have to find area of the square. From that, what we have to do? Area of this part, no remaining part. Let this be part 1 and let this be part 2. So we need to remove those two parts. Is it clear? Then we will get the area of this design. So how we will find the area of this white part 1? So white part 1 means, suppose this is a square. For example, this is the square and here it's a quadrant. And we need to find the area of this part. What you can do? You can find the area of this entire square, and from that you subtract the area of this quadrant. So you will get the area of this part 1. So that is what we are going to do. So let me name it. This is A, E, C, D. Now, first area of shaded region is equal to area of square minus area of part 1 plus part 2. So first area of part 1. Area of part 1 equal to area of square minus area of quadrant. Which quadrant? Quadrant A, B, D. So area of square is 8 into 8, 64. So area of square equal to 8 square, that is 64. So this will be 64 minus area of quadrant 1 by 4 pi r square. So 1 by 4 into pi, 22 by 7, r square, 8 into 8. So simplify. Simplifying 4, 8, 2 times. So 64 minus 22 into 8 into 2. So 22 into 16 will come. That is 350 by 7. So LCM is 7. So 64 into 7, 448 minus 352 divided by 7. So which is equal to 448 minus 352. Which is equal to 96 by 7 centimeter square. So this is area of white part 1. So area of white part 2 also the same, no? So what I can say, area of part 1 plus part 2. Add them. 96 by 7 plus 96 by 7. So it will be 192 by 7. Now area of the shaded region equal to area of the square minus, so area of shaded region equal to area of square. Area of square is 64 centimeter, this minus this. So 64 minus 192 by 7. So again 7 is the LCM. So 64 into 7 again 448. 448 minus 192 divided by 7, which is equal to 256 by 7 centimeters square. This is the area of the design. So that is end of this exercise, this part and this chapter. Thank you.